It's part 4 now, and we're in the central nervous system, the spinal cord, page 472, and we dealt with sensory pathways in the house wiring, and now we're dealing with motor pathways. Okay, so we're dealing with a couple of different things going on here, and at the heading, I'm listing things as either direct or indirect, and the easiest way to think of this is that we're going to regulate, in this case, pyramidal. Direct means that I'm going to do something, and it's going to be based possibly, on information that I got from the cerebellum and the basal nuclei, but also not the basal nuclei. Yeah, the basal nuclei. Yeah, exactly. The basal nuclei will utilize dopamine to smooth out or to adjust pressure and that sort of thing. And so the indirect pathway over here is actually starting at the level of, how shall I say, red nucleus activity here. Remember, we have dopamine, and it's regulating the activities of the basal nuclei. So how smooth have I done this? Have I used the right amount of pressure? Can I regulate pressure and smoothness and that sort of thing? So very complex, actually, as it turns out. So here's the direct pathway right here, and I'm just going to be somewhat minimalist. Here I'm initiating something going on with regard to the motor activity. Okay, it's going to come down, and let's follow this pathway right here. The cerebellar peduncle is passed through here at this particular level. Okay, and I'm sorry, the cerebral peduncle, not cerebellar. Of course, at the cerebellar peduncle, we're also going to have information going over to the cerebellum to make adjustments. Okay, but this is the cerebral, and it's going to come down here to become the pyramids. The pyramid is going to go through its decussation. Okay, so now some things decussate and some things don't. So on this side we have decussation, and on this side we don't have decussation at the pyramid. So there are some in different categories here. So if we don't have decussation, then we're going to end up with decussation at the level of exit. Okay, and this particular example is going to be the ventral corticospinal. So ventral corticospinal, think about that for a few seconds. Cortico means cortex, spinal means spinal. So that already tells you it's a motor neuron, okay, because it's going from the cortex of the brain to the spinal cord. That is to say, it's moving down. Okay, so if we have a ventral corticospinal, it's going to actually be a single neuron, and it's going to come all the way down. Do you see that? Single neuron, first order. And it's going to cross over and then synapse in the ventral horn. The ventral horn is where we carry all of our motor neurons for doing stuff with skeletal muscle. Okay, so it's going to cross over at that level, go out. We're going to use the musculature. Then let's consider up here we have another pathway. It's going to come on down, and it's going to go through the cerebral peduncle. It's going to stay basically same side, and then it's going to go through the pyramidal decussation. Now it's crossed over, so it doesn't need to cross over anymore, and it's going to come down here and go to the ventral horn, and it's going to operate a muscle over here. And who's this guy that's already crossed over? It is the ventral. I'm sorry. Did I say the wrong thing before? No, I didn't. No, so this one that we just did, the second one, is this guy, because it decussated. So that's the lateral corticospinal. They're both corticospinal, but the one that crosses over at the level of the muscle is the ventral, and the one that crosses over at the medulla before it gets down to the level of the muscle, that's going to be the lateral. So we either are going to go down through the ventral or the lateral. the ventral is going to cross over at the level at which you're operating, and the lateral is going to have already crossed over, okay, and go out. So we have ventral and lateral corticospinal tract, and then over here we have the little adjustment indirect pathway here, rubrospinal tract. And so it's starting with a red nucleus, and it's picking up all of its dopamine activities there. It's going to come on down, and it's going to make adjustments. What kind of adjustments will it make? It will make adjustments to axial muscles that maintain balance and posture. So a lot of your postural reflexes are based on the grace, shall we say, and the smoothness of basal nuclei and cerebellar activity. And then we have muscles controlling coarse limb movements. So there's sort of like a general type of momentum that we can create. And there's head, neck, eye movements, etc., that follow objects in a visual field. So these are all what are referred to as multi-nucleal pathways and indirect pathways. Okay, so this is an important detail because if you're doing sports or you're doing some sort of activity that requires you to have special skills, then you use a lot of these, and you develop these indirect pathways and all of the association cortices necessary for storing information. A lot of times people, when they say you're going to throw the ball, you're actually throwing it with your hip or with your feet, in essence, that it's your posture and it's the momentum that you create with the twist of your body that helps you throw the ball. The same thing with batting, that you bat with your waist, that you spin at the waist. Or if you're a Tai Chi person, you'll notice that a lot of the movement is in rotational movement and not actually with striking with a fist or that sort of thing. That in fact the hand and the body are more or less moving together, and you're twisting your body, right? And so so there are these sort of larger, more general movements that sort of bring you to that final movement that you're about to make. Okay, so that concludes this chapter here on the spinal cord.